Ewan Garden. Ewan is going to talk to us about advanced analytics with Azure Synapse. Adi, did you have anything to add? Sorry, I just steamed through that segment.
I was just curious to learn how they handle data skews, but this is something we're going to post as a question, and I'm looking forward to hear that response, because I know one of the challenges we have with data are data skews, basically when the data are not distributed in a uniform way, and we still want to make sure we have the fastest queries we can have. So yes, we'll address it later. Thank you.
Okay, thanks. So Ewan, yeah, you're going to be talking about advanced analytics with Azure Synapse, and I'll let you take it there.
Okay, you should be able to see my slides by now. Okay, I'll assume people can see the slides unless Brian yells at me. Well, welcome everybody. It's been quite the high-paced day so far. Hopefully we can keep that up. So I'm going to talk about doing advanced analytics. I'm the program manager for our Spark work, but I've also been responsible for some of our analytics work. And then we've kind of added more people to the team, and that's been taken over now. So that's what I'm going to focus on. So I'm going to focus on Spark and just educating people on Spark a little bit with some slideware. And then we're going to drop to demos, and we'll spend the rest of the time as much as we can just walking through the product, because I think it's a little easier to understand that way. So one of the questions we get asked about Spark is, what should I be using Spark for, and how is this different than open source Spark? Doesn't Microsoft just take open source Spark and ship it inside of Synapse? And the answer is no. So there's a couple of different things here. The first thing is that today we're supporting Spark 2.4. We're working on Spark 3.0. You'll see that at some point in the future. And after talking to lots and lots of customers, we decided to settle on something we call a managed job service form factor. And what that means is our clusters are very fast to start. They're very aggressive about auto-scaling down and also about shutting down, although you can override those settings. So the idea is you submit a job, we start up the cluster, we run the job, then we pause for a period of time that you decide, see if there's any more work that comes in, and if there's not, then we shut down again. This is one of the pieces of feedback we've had, because lots of people are really scared about leaving large Spark clusters lying around. So they size them too small, or they just don't give the right number of resources to the members of their teams. And so here you can have a very large cluster, it spins up quickly and spins down again. And right now, it's about 2.5 to 3.5 minutes to spin up a cluster of 60 nodes, size medium. For more than that, it goes to about 5 minutes. But 2.5 to 3 minutes is what we're hitting regularly right now. So that's what we mean by a managed job service form factor. Also, as part of that managed service means that you don't really have to worry about a whole bunch of the management infrastructure and upgrades and versioning and making sure the right versions of Spark are on the machine. We do that for you. And because the job service form factor tends to cycle the machines very often, then it means we can pick up patches and fixes, and you don't have to schedule cluster downtime and things like that. And then the last thing is our team actually produces 3 versions of Spark. We produce one that's internal only to Microsoft. We produce the one that we're talking about today, which is Synapse. And we also produce the one that's in HD Insight. Now, the difference between HD Insight and Synapse is pretty dramatic. And that's by design. They're designed to solve different problems for different classes of users. So HD Insight is not a job service form factor. It's designed to bring the cluster up, leave it running around. You can go ahead and do it a job service if you want to, but that's not what it's optimized for. It also gives you much more control. So SSHing into nodes and things like that, which we don't allow on the Synapse side. So that's the basic Spark, and we host it different ways, as I was saying. But then what we do is we go ahead and we add a whole bunch of Microsoft innovation to that open source. And the thing we spent the most time on so far has been performance. And that's because, everybody wants to be faster than the pure open source implementation. And so we work very hard at delivering that capability. And we've made tens of thousands of lines of changes, and we're actually working on a document that's going to document all of that. But as it stands today, the Synapse Spark is twice as fast as open source Spark for a particular set of benchmarks which we use, which are well-published benchmarks in the database industry. And we'll continue to evolve our performance development approaches. Because it turns out that if you have a large distributed system that's using cost-based query optimization, and you have a bunch of people kicking around in the org, like the people that were supporting Charles's demo in terms of some of those crazy queries he likes to run, who spent 25 years doing cost-based optimization on query processors, then they can apply that knowledge skill back into something like Spark, and not just into SQL Dedicated or SQL Serverless or Azure SQL or some of these engines. So we're able to take some of that learning that's been going on for those last 25 years and apply it into Spark. And you'll see some of that documented, as I was saying. Project Hummingbird is a really interesting way of dealing with ML. So if you take traditional classic ML, it's not super efficient to do batch scoring on it. Charles showed you using the predict function a little bit earlier on. And so what Project Hummingbird does, and the Hummingbird, there's a sample out there and the bits are in Synapse today, but it's in preview form, is it takes a traditional ML model expressed in Onyx format, and it goes ahead and it turns it into a series of tensors. And for those of you who are not ML nerds, tensors is just a different way of executing ML models. And then it runs much faster, but it'll run even faster with GPUs. And so this allows us to get a performance speed up in the batch scoring. If you're not an ML nerd again, then we do training, which is where the model learns what the characteristics of the data are. We then validate that model with a test training split or a cross-fold validation. And then on the other side, we go ahead and we make use of the model. And that's what Charles is showing you with the predict function. And so it makes that predict function run much faster. But we've also integrated in cognitive services. And so while it's great that you can consume models that are produced, who's going to produce those models for you? If you don't have data scientists in your organization, how do you go ahead and do that? And I'll show you a couple of ways that we can do that as part of the demos. But cognitive services is a series of pre-built models from Microsoft that we train, we manage, we maintain, and we make them available. And so we have integration in with a subset of those services. There's actually quite a lot of them that we think are going to be the most interesting ones, and we'll continue to add more of those over time. And so you're able to go ahead and score on top of your data using those existing cognitive services models as if you had developed them yourself. Hyperspace is a complete indexing implementation that we've built, and we actually open source, so you can deploy Hyperspace on other Spark engines. We make heavy use of it as part of our performance improvements, and it's a technology that will continue evolving. .NET for Apache Spark. We're going to talk a little bit about Spark's extensibility in particular as part of this conversation. And it was great that we have PySpark and we have Scala and we have Spark SQL, but a lot of Microsoft customers they're okay with SQL, but they're not so familiar with PySpark, and they're certainly not familiar with Scala. And so we put C# into the mix. Technically, you can use F# as well, but mostly the usage we see is of C#. And you can write programs in C#, and I have a very simple example I'll show you. You can also write user-defined functions so that anybody else can actually consume your work. And that's a pretty powerful capability to be able to use that language. We have a new caching and shuffle service coming that dramatically improves performance. And then Synapse Link, I think Savine's going to talk about in detail, but Synapse Link appears in multiple places inside of Synapse. And it makes it very seamless for us to query other data sources. Cosmos DB is the one that we've shown for quite some time. And that's the one that allows us to just reach into Cosmos DB and read the data directly into a data frame inside Spark. For those of you who know Spark, the data frame is a tabular data structure that is used very heavily. And from there, we can just process it like it was any other data frame, as if we'd loaded it from disk, or as if we had done anything else with it in terms of how we'd constructed the data frame. You can do it in code, you can read from disk, you can read from HTTPS. Then the last thing we do is we listen to customers a lot. We have the advantage of having had HD Insight in market for a number of years. We have the internal customers as well. And so we're able to spend a lot of time with internal and external customers. And what are the things that are really important to you? So we have an improved notebook experience that I'm going to be showing to you. You can switch it on. It's not on by default for external customers. We have operationalization for notebooks that we're continuing to evolve. And what that means is you can take a notebook and in 2 or 3 clicks, you can turn it into a notebook which gets executed in a Synapse pipeline, and therefore it can be scheduled, it can be triggered. We have a Scala experience inside IntelliJ. Lots of people don't know this. More than 80% of the Scala code that's written in the world is written inside of IntelliJ, and it's a great experience. And so we've written a plugin for IntelliJ that makes it very easy to write Scala programs in IntelliJ, test them, and then go ahead and deploy them up to Synapse. Scoring and training wizard, I'm going to show you both of those, so we won't talk about those in any depth. Delta Lake. Delta Lake's a very popular transactional Parquet format that was introduced by Databricks, and they open sourced it, and we include support for the open source version. Extremely popular with many customers. MS Spark Utils is a series of utilities to just make things simpler to do when it comes to executing one notebook from another notebook, to getting credentials. There's a variety of different capabilities in MS Spark Utils, and we'll continue to add more there. And it's just to simplify the API surface area. And then the last thing is, and Charles briefly touched on this, is metadata integration with Synapse SQL. And what that means is that when we create tables in Spark, for example, they can be seen in serverless SQL today, and they'll be seen in dedicated in the future. And when you create tables in dedicated SQL in the future, like Charles was doing, then you'll be able to see them and query them inside of Spark. So one of the goals and the principles that we have is of shared metadata inside of Synapse, so that every compute engine can make use of the data produced by every other compute engine without having to dump and reload. And this is one of the things that Charles touched on. Okay, enough with the slides. Let's go ahead and we'll take a look at the product. So I'm going to fly through a bunch of different scripts and notebooks. I'm not going to run them live because we don't have a ton of time today. So this first one here is just going to set up some data that we're going to use in other places. And so here we're taking the New York Taxi yellow cab data. If you're not familiar with this, it's a data set which tracks 1.5 billion cab rides in New York. And you get all sorts of interesting information like pickup location and how much the tip was and whether there was a tip and how much people paid. So in this case, we can read it live over the internet, but it's not super fast. So I have a cached version that I run locally inside of a storage account, and it's 150,000 rows, which means things tend to run a little faster. And here you can see the output from that. And I have the choice of a table view, or I can go ahead in here and I can look at a chart view. Not the smartest default in the charts. We're going to do some work there. I can also open up Spark History Server and take a look at what was going on when this was being run, this application. And if you've never seen Spark History Server before, it's quite intimidating. We'll come back to it once it's loaded. And I can take a look at metadata. You know, if you're not a Spark person, then all of this is kind of going over your head. If you are a Spark person, you're sat there going, well, yeah, Ewan, nothing new and exciting there. Okay, so let's take a look at the first thing that starts to show the power of Spark here. So the language we're using is up here. It is PySpark, which is a special Python variant that runs inside of Spark. But down here, you'll see we have %% Spark. It's called a magic, and it allows us to run Scala code. And so what we're going to do here is we're going to create a database that, if it doesn't exist, called New York Taxi Cab. And then we're going to go ahead and read this data set here from Small SQL Dedicated, which is the engine that Charles was just talking about. And then we're going to write it back out again as a table. And so here you see some of that interop coming into play. We're doing it with Scala because this SQL Analytics driver is only available in Scala today, but we'll look at adding other capabilities later. Here you can see information about what was actually executed. In this case, we used 40 cores. Executes nice and fast. And now we can start pulling data back out again, just to verify that what we did actually worked. And so this is a copy of the data that was further up. Now we can start doing some manipulation of the data and ready for analysis. And you can use any of the compute engines to do analysis. So you can use serverless SQL. It's great for doing ad hoc analysis. And then you can use dedicated SQL for doing more structured analysis, some of the stuff that Charles was showing. And then you can use Spark to do either, although it tends to work a little better with the unstructured analysis or the ad hoc analysis, but it can work just as fine with tables as it does with any of the other structures. And so here you see that we're just going to pull the data out, and we're just going to do the sort of thing that I would do with a relational database engine. I'm going to compute some aggregates in here. I'm going to add a filter in here to filter out only valid data. So, hey, we only care about trips which are longer than 0 in the passenger count where it's more than 0, because otherwise it doesn't actually make sense. And we've already saved this table away, so we've created this new table called passenger count stats. Okay, and this is what passenger count stats looks like. Here we can see what's the, for passenger count of 1, what's the sum of the distances, and what was the average trip distance. And there's a couple of weird things in there in the data that we'll have to take a look at and see if they need cleaned up. And then at the very end, we're going to go ahead, I'm going to go ahead and write that again using Scala, and we're going to go ahead and write it into our SQL Analytics store. so that we now have inside of the SQL dedicated store, we now have copies of this data that we processed. The goal in the long run is you won't have to copy the data, that you'll just have a pointer to it. All right, so let's go ahead here and we'll take a look at the dedicated. So now we're going to go ahead and make use of that. Except there's something wrong with the metadata. We'll try running that again. Let's just go see. So here we're just going to compute on top of that data. So here we can see trip distance miles. Remember, this is on top of the raw trip count. So this is trip, not passenger count, which was the summary data we just posted. So I'm going to compute the trip, sum, and average, and I'm going to go ahead and I'm going to filter by the same things that I filtered by earlier on, and I can keep going. And so now what I've done is I've done the same thing twice, but I used Spark to do it one time, and I've used our dedicated SQL engine to do it the other time. And if we go in here, oh, there we go. It's the window I want. Here I can actually go ahead and select the data. Here I can go after the raw data. So this is the power of SQL dedicated, but I can also do cool things like this. So if I bring out the storage browser, you'll see here we have 3 databases. And let's go ahead and we'll pick the New York Taxi database, which has passenger count stats. And we'll go ahead and say we want a new SQL script here. And you'll see it's connecting to built-in. Built-in is the serverless engine that we have, and it's going to do select top 100. And remember, this is passenger count stats, so this is actually the aggregated view. And so now what we're doing is this is on demand. So it's going to spin up some query resources. There's no dedicated cluster lying around, and it's going to go ahead and pull it out. So what I'm trying to show you across these 3 engines is we can have data in the lake, and it can be in files or it can be in tables in this particular case, and we can pretty much use any of the engines to analytics that we want to. And we can do different types of analytics in different places. So let's go ahead and take a look very quickly. This is a very famous example. This is the word count example that it does inside of Hadoop, except if you take a look at the language up here at the top, you'll see it's C#. Now, this is a very small subset, so you can see that the words .NET appears 3 times, Apache appears 2 times in this very simple quote, but it gives you the idea. I also get charting. If I want to go off and compute a histogram and display that, I can go ahead and do that. And so C# is very much a first-class language inside of this compute engines that we have here. All right, let's hide the storage window away. Now, things that are very powerful about Spark is, first of all, there's a lot of extensibility, as you can see here. So there's lots of functions that and capabilities we're adding. This is the one I want to call out here. And I'm going to scroll through this. If you're familiar with the yellow cab data, this is just simply we're going to downsample the data. Then we'll do a little exploratory data analysis. So we're going to do some charts, which take a look at some of the usage patterns inside of the data set. So here we can see the tip distribution. And so the tip amount is 0 for a lot of people. That's kind of mean. And there's a little bit of a nice little area here, so $2.50 for 250 people. So we can see the distribution then of the tip amount. Here we can see passenger count and see what their amount of tip is in relation to passenger count. And then finally, we can take a look at tip amount by fare amount. And you can see here, there's our 0 data down at the bottom. A lot of people, no matter how far they're going, give 0. And then there's a somewhat interesting pattern here. There's a couple of them which show that as the distance increases, then people are actually willing to pay more. So that's good. Not everybody's being super cheap. So we'll keep scrolling down here. There's a bunch of featurization, which is just computing columns and dropping things. Then we do some nerdy ML stuff where we encode things. Then we split the data and we say, hey, we're going to do some training and we're going to do some testing. And we're going to go ahead and do a logistic regression in this case. We're going to use area under the ROC curve as our way of assessing success. And I'm going to take a look at this final chart. And that's very much what you want to see between true positive rate and false positive rate. You want to see it go up very steeply and then get to the top and stay that way. So I just scrolled through an example very quickly. This is in our documentation and it's in our samples website. So you can go ahead and take a look at it there. And this is all done inside of Spark, with the exception of converting the data into format that matplotlib can render, which means I have to convert it into Pandas. So this is PySpark this is done using, not done using Python in this particular case. And so let's go ahead and we'll switch to this one. Now, what starts to make ML really powerful in these sorts of environments, and this is another example uses New York Taxi Cab yellow data, but I'm going to scroll down through this. This is a slightly simpler version. This one actually uses pandas. So it doesn't work with such big data sets, but you get the idea. And here, what we're doing is we're going to use Azure Machine Learning. One of the hard things about doing ML analytics is you might need thousands of experiments to get to the finish line. And so from that perspective, how do you know which one was the best one? Which parameters did you have? And Azure Machine Learning provides a great capability to allow you to do that. So that's what we're doing here is we're setting up some of the metadata that's required to use Azure Machine Learning here. And here we're actually going to go ahead and not just log the information, but we're going to use something called AutoML. So even for experienced ML customers, trying to work out which algorithm to use, which featurization strategy to use, where to start your hyperparameter suites can be a little tough. And if you don't have a ton of experience, if you're a brand new data scientist, then it can be intimidating and it's hard to get right. And so AutoML uses a whole variety of different techniques to take a look at data and try different strategies. It tries different algorithms, it tries different featurizations, and it also tries different parameter boundaries. And then it pops out the other end and it says, hey, here's the one I think is best based on the criteria you gave me. And so that's what we're setting up here is we're just setting up a regression AutoML run. And then we'll keep going down here. Now we create an experiment. And we can see we're going to take a look for the best run. And I'll just scroll down the bottom here. And then we're going to go ahead and publish that and take a look at the results. So what we've done here is we did an auto, and it takes a little while to run. What we did was we used automated ML, so AutoML, to take a look at that exact same data set that you saw all that code that I wrote by hand. And it's going to pick the best answer, and actually picks a better answer than I do in terms of featurization, parameterization, and also the algorithms that it uses. But you have this big corpus of data, and it's in Azure Machine Learning. It's not something unique to Synapse. So if your data scientists want to go inspect the work that was done by the more junior data scientists in the org, or by the kind of the no-code, low-code data scientists, then they can go ahead and do that, and they can see all the details they want to be able to see, and they can approve models being published. All right, let's fly around a couple of other things before we head out and take some questions, perhaps. So if we go, oh, that's not what I meant to do at all. This is when I meant to go. So if we go in here, back to the databases, you'll see here that we have a dedicated SQL, and we should have a table in here. Go back metadata. Okay, there's passenger count stats, but there's also trip. So remember, trip was the thing that we were actually doing all the ML on. So what are some of the options that we have here? Well, this is kind of cool. I have this machine learning option. Or I did have a machine learning option. Where did it go? Okay, and I can go ahead and enrich with an existing model. So that's essentially what Charles was showing you, except he did it in code. I can go ahead and use a wizard to do it. And it's going to go ahead and enumerate my Azure Machine Learning workspace. There's nothing in there right now. I can choose a different workspace, but that's the only one that I found in right now. I'm not going to go through the wizard steps here, but what it does at the end of the day is it generates the capability to do the predict function that Charles was showing you. Let's switch to a different table. So we'll go ahead and we'll switch to trip, but we'll do it over here. Machine learning. Now we have enrich with an existing model, or we have with new models. So let's go ahead and do enrich with existing model. Again, there's no models in that demo workspace that I'm using, but we do have cognitive services. And so if I want to do anomaly detection or text analytics, I can go ahead and just use one of these models. And we'll zip through this. Let's see. No, I need to select an account here, so it won't work. But we can choose one of these two cognitive services, or if we had our own models, they would exist here as well. And as I said, we'll continue to add more to the cognitive services list. And I can go ahead and apply that and do batch scoring on top of my trip table. What's even more interesting is think about all this code, even the AutoML stuff that I showed you, it's a lot. And so what we have here is we have a wizard. And here's the workspace I'm going to use. Here's my experiment name. Here's what I want you to call the model. We'll go ahead and we'll pick the column that we want to predict. Let's say we want to pick the tip, let's do tip amount. So we'll go ahead and predict the tip amount. Which Spark cluster do you want to use? We'll use this one that we've got here. And so we'll do a regression model. How do you want to validate your model? How long do you want it to take? What's the max number of iterations? And do you want it to be ONNX compatible? If you make it ONNX compatible, then it can be consumed in the predict function that Charles showed you. So I can either kick the run off, or I can simply look at it inside of a notebook. And so here, this code will look very familiar. It's very much like the code that you just saw. There's the AutoML config. There's display HTML to actually render a nice, pretty picture. And there we're going to go ahead and register the winning model inside the ML repository. So we've looked at a series of different capabilities that we have here in the product to do analytics on data, whether it's BI analytics with group bys and joins and things like that, or whether it's more sophisticated in terms of machine learning. We've looked at how we can consume those. The nice thing about both of our SQL engines is they are just SQL engines. And so anything that understands a SQL endpoint can go ahead and connect to them and you can consume them. That means tools like Power BI and the like. And in fact, if we go in over here, I've actually got a Power BI model over the top of that summary data. So if we take this passenger data and, oh, that's not playing nice. So if we take the passenger data and we'll add a line chart over here. And so we'll add the passenger data as an axis, and then we'll add the other two as values. Okay, so now inside of Synapse, I'm also able to build and validate some reports. All right, at that point in time, I'm going to pause. We have 4 minutes, so I'm going to beat Charles and actually have time for questions. So let's go ahead and see if there are any questions.
Hey, great stuff. Adi, did you have any questions?
Yes. Thanks, Ewan. It was great. Questions about the different projects that you're working on. So Project Vegas, is that an open source or something that is proprietary for Synapse?
Currently, it is proprietary for Synapse. Like a bunch of the technologies that we build, like the Spark .NET implementation inside of Spark, the hyperspace indexes, we'll have to decide what we want to do with that. There's also all of the performance enhancements we made to open source Spark to get it to twice the speed of the current 2.4 open source. We'll have to think about those ones and which ones make it back. We do already have members of the team contributing PRs into the Spark code base, but we'd like to get a few more.
Cool. And regarding hyperspaces, so you mentioned it's an open source. So if I'm a community member who would like to contribute, but I'm not a Microsoft employee, is there a specific process I need to go through?
Go to GitHub, take a look at the code, look at the guidelines for committing to the project, and then go ahead and submit your first PR. Currently, it's managed under the Microsoft open source umbrella. We're going to either go to Linux Foundation or Apache Foundation at some point, but just to allow us to get the thing bootstrapped, it was easier to do it under the Microsoft open source umbrella.
Cool. All right, Brian?
Yeah, a couple of things I wanted to add, a few things that Ewan covered. Just want to show them on my screen here. We've got any questions you want to ask, by the way, Ewan, if you go to aka.ms/learntv, you'll see our interactive chat there, and you can ask Ewan and others any questions that you might have, and we'll be monitoring that during the rest of the sessions, which is about 30 minutes. But here on my screen right now, if you could show my screen, I'll bring that up, hopefully. Thank you. Yes, all of the links that I'm going to be showing here today are at aka.ms/thelaunchspace. But I wanted to highlight that we have a lot of Synapse documentation. There's kind of 3 levels for it. So there's some Synapse analytics. There's a tutorial section as well. Ewan, I noticed a lot of the stuff you're talking about is actually here using Spark and Hive tools and PySpark and a few other things. There is a great tutorial that I found kind of buried down underneath how-to guides, use notebooks and IDEs, and it's connect to Spark pools with VS Code. And it's got a cool way of actually interacting with a lot of the things you showed in your demo just from one pane of glass, if you will, one IDE that we have there. And you install a couple of extensions and then basically run through the setup. And it's pretty cool. The tutorials are awesome. Aside from tutorials, the next level we have for that is the Microsoft Learn TV. And once again, the links are at aka.ms/learntv and also at aka.ms/thelaunchspace. But the difference between Microsoft Learn and the regular tutorials is it's interactive. And if you sign up, you actually can get some points and things for going through this. And it is directly related to certifications at Microsoft as well. So a little extra beyond the regular documentation and tutorials. I urge everyone to check it out.